I'm going to start going over the 7.2 quiz review. This is the morning quiz review. So number one says determine the volume of the solid generated by revolving the region bounded by this graph y is equal to 6 minus x, okay, this linear function here, by y equals 0, that's the x-axis, y equals 0, y equals 4, okay, linear line here, and finally the y-axis, okay, vertical line. Okay. So we have the shaded region, and each of those lines that we listed contribute as boundaries for our shaded region. And so now we're going to look at the axis of revolution, which in this case is, for part A, is x equals 0. And so that'll be right up against the graph. There's no gap between the shaded region and this and the axis. So we know that this will be a disk method. And when we draw our radius, we're going to extend from the center. So remember, your axis of revolution is the center of your object. You're going to extend from the center to the curve, or in this case to our linear equation. And so this will be right minus left because we drew a horizontal radius. So this method, right minus left. If we are doing right left method, then we know we have to be using everything in terms of y. So we're going to rewrite our equation. Initially the equation was y is equal to 6 minus x. We're going to rewrite it as x is equal to 6 minus y. So then we do right minus left. So the right endpoint is on this 6 minus y graph. The left endpoint is on the x equals 0. So we say right minus left, 6 minus y minus 0. And that will represent our radius, r of y. Our bounds are going to be from the lowest y value to the highest y value, so from 0 to 4. So our volume formula, this disk method, will be pi big R squared from 0 to 4. Okay, plug in our calculator, we'll get 208 over 3 pi cubic units. Part B, we are dealing with the same shaded region, but now we're going to be moving around the line x is equal to negative 3. Now, relative to the axis, we're going to look at the shaded region, and we see that there is a hole, so we know we're going to be using the washer method. So starting at the center of your graph, the axis, you're going to draw your big radius to the further curve, the further line, the 6 minus y. And then starting on the axis, you're going to draw to the inner curve, to the closer line, which is the x equals 0. Okay, so now we're ready to find big R and little r. So the right endpoint is on this graph, 6 minus y. The left endpoint is on the graph, negative 3. So 6 minus y, this is the right graph, minus the left graph. The two negatives cancel out, combines with 6, so we get 9 minus y as big R of y. Okay, little r, right endpoint minus the left endpoint. The right endpoint is at 0. The left endpoint is at negative 3. So right curve minus the left curve, 0 minus negative 3. The two negatives cancel out, we get a positive 3. So we're going to use washer method, which is pi big R squared minus little r squared. And the bounds are going to be the same from 0 to 4 because we're using the same region and we're using right minus left method. Okay. Plug in our calculator, we'll get 496 over 3 pi cubic units. All right, number 2, determine the volume of the solid generated by revolving the region about the curve y is equal to 4 minus x squared and y is equal to 1. So we have a parabola that opens down and we have a horizontal line at y equals 1. Okay. So here is our parabola through the vertex at 0, 4, and here's our line y is equal to 1. So we're going to see the shaded region here. So first part, we're going to be revolving the solid this shaded region around the line y equals 5. So we have our axis of revolution at y equals 5. And in relation to the shaded region, the axis will be, there will be a hole between the axis and the curve, or between the axis and the shaded region. So we know we have to use washer method. We have to draw two radius. So starting on the axis, we're going to draw to the further line or graph on the shaded in the shaded region. So that's big R. Okay, little r, we're going to draw to the inner curve, to the closer curve. And so we drew vertical radius, so we know we're going to be using top minus bottom method. So big R will be the top. So the top of this radius is on this y equals 5, so that'll be 5, minus the bottom of this radius, which is at 1, so 5 minus 1, that's equal to 4. Little r, we look at the top of the radius, which is on 5, and then the bottom of the radius, which is on the 4 minus x squared. So 5 minus 4 minus x squared, distribute the negative through, we get 1 plus x squared. Now to find the bounds, we see that the bounds will be this x value and this x value, the furthest left and the furthest right in the shaded region. Now to find these 2 points, we have to set the parabola equal to this line y equals 1. We're looking for x values. So 4 minus x squared, set 4 minus x squared equal to 1. Bring x squared to one side, subtract the 1 on the other side, we get 3. So x squared equals 3, so that means x is equal to plus or minus root 3. So these x values are negative root 3 and positive root 3. So volume, we're ready to plug into our washer method. So pi big R squared minus little r squared. The bounds from negative root 3 to root 3. In our calculator, we'll get 38.798 pi cubic units. Okay, the same shaded region, we're still looking at a parabola that opens down and a linear horizontal line at y equals 1. Okay. So within the shaded region, we're going to have a washer method, because our axis of revolution is at x equals negative 4. So relative to the axis, there's going to be a gap between the shaded region and the axis. So we use washer method. We create 2 radius. The first radius will extend from the center, which is the negative 4, to the further curve, which is at root 4 minus y. And the x equals negative 4, the little radius will extend from x equals negative 4 to the inner curve, which is the negative root 4 minus y. Okay, the way we found these equations is we knew that the parabola is y equals 4 minus x squared, but because we're doing horizontal radius, we're going to have to rewrite our equation, solve in terms of x. So if we solve for x squared, we get 4 minus y. Take the square root of both sides, so x is equal to plus or minus root 4 minus y. So the positive, so this side is the positive root 4 minus y. This side is the negative root 4 minus y. So then big R is simply positive root 4 minus y minus a negative 4. Little r is negative root 4 minus y minus negative 4. So we simplify that. So big R is simply just going to be root 4 minus y plus 4. Little r is simply going to be negative root 4 minus y plus 4. We're ready to plug into our volume formula for this method. Our bounds are going to be from the lowest y value to the highest y value. The lowest value is at the lowest value should be at 1. Okay, so this should say 1. And the highest y value is at 4. So we're going to go from 1 to 4. pi big R squared minus little r squared. And because of that mistake there, our volume is going to be less than that. Let's see if I can find that. So if we plug this in, we're going to get we have, okay. So for y sub 1, I plugged in the big R. For y sub 2, I plugged in a little r. And I do have to make an adjustment here. The lower bound should be 1 to 4. So that will give us a volume that will be less than what is said there. Okay. So we get 55.426. So 55.426. So we get 55.426 pi cubic units. So again, the bounds are going from 1 to 4 and not from 0 to 4.